Hi everyone, welcome to my presentation on the classification of operating systems. I am Sharmila from the Department of Computer Science and Engineering. Today I'll take you through the different types of OS, their characteristics and their uses. Let's get started. Before we dive in, let's quickly understand why an operating system is so important. An OS is basically the backbone of any computer system. It manages hardware, software, and user interactions. Some of the key functions include process management, memory management, and file management, and security. Now let's Now let's look at the different types of OS. They are classified based on their functionalities. These include single-user OS, multi-user OS, batch OS, time-sharing OS, multi-programming OS, and more. Let's break them down one by one. The single user versus multi-user OS. A single user OS allows only one person to access the system at a time, like Windows 10, MS-DOS, which is used in personal computers and workstations. On the other hand, the multi-user OS supports multiple users at the same time. Think about large servers running Linux or Unix, where multiple users log in remotely, which is used in mainframes, cloud computing environments, and enterprise servers. Then batch OS. In a batch OS jobs are processed in groups or batches without user interaction. It's commonly used for things like payroll processing and banking transaction. Like examples IBM mainframe OS, early versions of Windows, which is used in scientific computations also. Then time sharing. Ever wondered how multiple users can work on a single system at once? A time sharing OS allows multiple people to share the system's resources efficiently. It works on the concept of CPU scheduling. In these, the examples like Unix, Linux, Multics. Users are large-scale multi-users environment like universities, banks. Then multi-programming versus multiprocessing OS. A multi-programming OS keeps the CPU busy by switching between programs, reducing idle time. Their characteristics were increases CPU utilization, which reduces the idle time of CPU. Then, as usual, Windows, Linux, Mac OS are the examples of multi-programming OS. Then the uses are general purpose computing systems are the uses. On the other hand, multiprocessing OS, which uses multiple processors to execute tasks in parallel, boosting system performance. Example include Unix and Windows Server, which is high performance computing data centers, which are the uses of multiprocessing OS. Then distributed and clustered OS. A distributed OS connects multiple computers to work as one system. Think about cloud computing, IoT systems, enterprise networks. Some examples like Amoeba, Mac, Google's Fuchsia, which is characteristics are decentralized control, high reliability, and fault tolerance. Well, this is the structure of distributed OS, which are distributed like a peer-to-peer computing, cluster computing, utility computing, jungle computing, in which the utility computing is divided further into grid computing and cloud computing. Then clustered OS. The clustered OS is similar, but it's mainly used for load balancing and high availability like Linux clustering. As usual, the uses are large-scale data processing, high process performance computing. in which the characteristics like used for load balancing and high availability works in failover mode. One system takes over if another fails. Then the network OS. The network OS manages computers over a network. It's used in LAN, WAN environment. Windows Server and Novel Netware are great examples. This characteristic supports file sharing, communication, and remote access. This is the structure of network operating system, like a server client communications. Then real-time OS. Real-time OS is used when timing is critical. There are two types: hard real-time OS and soft real-time OS. The, the real-time OS characteristics are process tasks within strict time constraints and also used in critical times or systems. When the types of real-time OS hardware and hard real-time and soft real-time. The hard real-time, which is strict, which means used in medical devices, guarantees that critical tasks must complete within a fixed time. Example, flight control system, medical devices, etc. Some of the uses are spacecraft, robotics, defense applications. Then soft real time, which allows slight delay, like gaming consoles. And streaming services are the example. Video streaming, online transaction, multimedia applications are the uses of soft real-time OS. Then mobile OS. Of course, we all use mobile OS daily, Android, iOS, and even KaiOS for feature phones. These are designed specially for smartphones and tablets. Then embedded OS is designed for specific tasks in devices like smart TVs, IoT gadgets, and even cars. It's lightweight and efficient. Well, those comparison of OS, here's a quick comparison of different types based on users, examples, and use cases. This helps us to how each OS is unique, serve different purposes. As technology advances, OS is also evolving. We are seeing AI powered OS, cloud driven systems, edge computing, and even quantum computing OS. The future is exciting. So that wrap up our session on OS classification. Each OS has its role from personal use to enterprise solutions. Thank you for watching. If you have any questions, feel free to ask questions.